I just want to show you an idea I had. I'm trying to demonstrate how the sun moves across the sky at different latitudes, and I was thinking about trying to figure out how exactly that can work. So I've got this mirror here, and it's going to it's not going to represent the Earth because this isn't wide enough to represent the sun's movement. So I'm going to get something else. So the idea is that at the center of the mirror, say somewhere right in the center, so that's my guess for the center, is you're standing at the center, and you're on this little tiny disk world, and we can change the sun's path. The sun is going to pass over this. At the equinox, at the equator, it's going to go like this. And then in the summer, northern summer, it's going to go up. And its path is going to go up, but it's going to be parallel. Its path is going to be parallel to the central path. Pretty much, like almost exactly. And then if you're going to the North Pole, you just move this to the corresponding to like this, and then you can see the sun's path to the North Pole at the equinox is going to be along the horizon. But I thought, well, this isn't perfect as a demonstration, so I'll make something bigger. So what I'm going to do, I've got two of these little cake things, and I'm going to mark the sun's declination on it. So at the equinoxes, it's 0, and then I'm just going to pretty much even these out, these numbers out, kind of average them to the longest and shortest days of the year. And I'm going to put marks on this at the correct declination. So this one is around 6 degrees. So 6 degrees will work for, where are we? April 6th, and pretty much for March 6th too. So this is what I'm going to do. I'm just going to put these marks, then I'm going to do circles around, cut off the tops, and put it on a corresponding piece of brown metal instead of the mirror, or sorry, round something, probably wood instead of the mirror. And then I'm going to swing it around and show how these little circles on it are going to, these little circles on it will correspond to different parts of the year all across the world. Thank you. I'm bringing this closer to the laser cross beam leveling thing, and I keep the lines lined up with the lines on the paper, and then I measure with this guy here. Like I can just see the line of it on the the compass. This is a model of how the sun goes around the Earth. Well, the Earth goes around the sun, but when the Earth revolves, it looks like the sun is going around the Earth. Anyway, the model contains a protractor on the inside, and the protractor is lined up so that 0 is vertical and 90 is on the horizontal. And originally I had hoped to have the model made with cylindrical see-through plastic or plexiglass or perspex, but I couldn't find it, so what I used instead was two cake covers from a dollar store. So I joined them together, and it was a pain to do it, but Ideally, a cylinder, and the rough dimensions would be what is it? The diameter would be twice the length of the cylinder, and then you have enough space to write numbers on the outside. So the Earth is at an incline to the Sun, and it's 23 degrees, and what that means is that in summer the sun rises 23 inches higher in the sky, or 23 degrees higher in the sky than it at its highest point than in the winter, or sorry, than at the equinoxes, and then in the winter it goes down lower. And it's a model that I think would be very beneficial in schools right across the world. It's a simple model that anyone can make. So ideally a cylinder rather than these two pieces stuck together, and I'll give you a demonstration of how it works. So here's the protractor. So you line up the protractor with 0 degrees. There. So this is what happens at the equator, and the sun, where's east and west, rises in the east at the equinox, and you always point your pointer at the center. So I have a little screw at the center to show shadows, and sorry, I'll put it around this way so you can see it better. So rises in the east, point at the shadow all the time, and sets in the west, pointing at the shadow all the time. Then you go winter, all that happens is I have a green line over here for 23.5 degrees, and you just follow the green line. So in winter there's a bit longer of a shadow on average than at the equinox. And at the equator it's exactly the same. In high summer, the bit longer shadow, oops, not keeping it straight on, but and there's other things, like potentially if you don't have a laser level, if you're in a poor place, you don't have a laser pointer or whatever, you could actually tie a piece of rubber band to the, well no you can't, sorry, I think I'm wrong, because this doesn't rotate. But you could actually have a rubber band and you could bring it around with your finger on the inside for each the different angles to demonstrate how the light would flow. So you don't even need a pointer, or this is the other thing I have. It's off a bike, and it shows the not off a bike, off a headlamp, miner's light, and it shows the shadows with this one. So so that's the equator. So now I'm going to go to my latitude, which is 55 degrees. So I just look through the gap here, go to 55, or sorry, not 55, 40, 49 and a half. So I'm going to go to, just have to fiddle around with this for a little while. There we go. So this is very close to my latitude, and you can see how very different the sun path is here. It's totally different, and this makes a huge difference to summer and winter. So let's see. I'm just going to check with this. I'll turn it a little. So hopefully you can see it better like this. So now at the equinox, so March say 22 and September 22, this is how the sun is shining. So it's much, much lower in the sky at the equinox. So just shine it like that. And I'll do it with the light too. So here it is at the equinox. So it starts here around, and it'll be 12 hours. It starts exactly in the east and comes around, oops, sorry, and to point it at this all the time. And you can see the shadow there. And goes down in the west exactly at due west. So now we'll go. I have other lines, like I have lines for every 15 days on it through the year. So this would be say 6th of June, then May 15th, etc., etc. And this one here is high summer. So we'll check high summer here. So the first thing you'll notice is that the sun actually starts off much, much earlier in the day. And it'll shine like this. So it's shining from north to east. And then, and you can probably see the shadow. That's the other thing too. Shadows where I live are much longer than they are in, say, Mexico or Ecuador. So we'll go around. So there's my shadow at midday. And then we'll continue on down. And oh, can't really, I don't want to get in the way. But this should be a really, really good demonstration for children all over the world to comprehend the difference. And I'm only going to do one more. Now I'm going to show you the North Pole. So this is the North Pole. So what happens at the North Pole? Well, this part here is for winter. So you get no sun in the winter at all. So until, and then the 21st or 2nd of March, it's the sun is going around just on the horizon. And here's the interesting thing. It goes right around, so it'll be on the horizon all the way around 24 hours. And then we'll wait, we'll go 2 weeks later, and this green line is where the sun is going to shine. So at the North Pole your shadow is going to be really, really long. So I have on this, I have a little spot in the middle, so I can exactly line it up with the green. So 2 weeks later your sun is going around, right around, oh sorry, I'm keeping it very good, but it goes right around, shining on the middle, because right around in a circle. So what actually happens is this, and you'll only recognize this in northern, really far up north, is the sun is actually spiraling higher in the sky. So it goes, I think it's, I can't remember on my book, but it might be 4 degrees in a week. At this point in the, or maybe it's 4 or 6 degrees in a couple of weeks. I don't have the book handy, I didn't think. But it'll spiral up through the summer until it gets to the 21st or 2nd of June. And at that point, this is the height of the sun in the sky. And it goes around, sorry I'm not keeping it very steady, but right around in a circle, and right around again. And so after the 21st of June, it spirals down back to 21st of September, where it disappears over the horizon and you don't see it again for another 6 months. And so I go back to my latitude because I forgot to do winter at my latitude. So there's me again. So way down here, and I forgot to do winter. So in the winter, so I'm back on the green line at this point. Sun. This is done in solar time, so it's not exactly the same as the time zones. So the sun is just up in the sky now, and oh sorry, this is west. Oh, I forgot. I got my sun going around the wrong way. I'm going to start in the east. So down here in winter. So the sun is just starting to shine here, which is, I can't see it, but each black mark represents an hour. There's 24 around there. So here we go again. So now the sun has just risen here, comes around, and just when you're doing it yourself, see how long the shadow is now? Because the sun is low in the sky. And come around. And really I should have something shorter here. Come around, and now it's gone. And another thing about solar, you can get these solar declination measurements throughout the year from various websites. But here what happens is the sun in summer and winter, in midsummer, midwinter. So this black line here I put in the wrong place. It should be a tiny bit. It was a measurement error on my part, and it's the same with error on that side. But it should be closer to the green line, which is 23.5 degrees away from there. So the sun moves across the sky very, very slowly in midwinter and midsummer, and then as it comes towards the equinox, the days are getting longer or shorter very, very quickly. Like you'll notice it even in a week how much longer or shorter the days are, and then it continues on, and once it gets past the equinox it slows down again. So the spiral of the sun across the sky is slowing down until it gets to 21st, well, is this June or, oh sorry, yeah, this is the shortest day of the year. So it's from here up, it's spiraling up in the sky faster and faster, reaches the equinox, and now it's spiraling up in the sky slower and slower until it's going very slowly around midsummer. So that means in the 15, 30, 60 days here, the sun is almost in, it only goes up and down a tiny bit, a couple of degrees, whereas in the 30 days here, it's very rapidly changing. Or sorry, the 15, 30, 45. So in this period here, it's changing very rapidly in this period, but around midsummer and midwinter, the change in where the sun's path is very slow. And just the nature of the Earth being on a slope to the sun. So I got the Earth here, and it's on this slope, and as it goes around the sun, the Earth's still spinning on the same axis, but how it's facing the sun is different. So I'll just move this out. So it's the same to move the sun as to move the Earth in this. Turn off my lights. So the sun, it just changes everything as it goes, as the Earth circles around the sun. So when the Earth is facing the sun in your hemisphere you're getting these much longer days. Yeah, as you go further north, and down around the equator it's not much different. Anyway, I'm going to, I better show you this a little better, what I have here. So as long as you can, I'll turn back on my lights, sorry. So as long as your demonstration can go from horizontal like that to vertical like that, you can demonstrate anywhere in the world with it. And you've got to do the declination angles from this point here. So your declination goes, the angle is done from here. But that can be calculated on a, can't calculate it on this because it's not a cylinder, but on a cylinder you can calculate it quite easily. And see what it's going to do. Oh, I'll just see if we can take it apart and show you what's inside. Or maybe I can't. I'll just take the camera off. Here we go. You can see I have the protractor here. This particular protractor has 2 holes in it, so it's very easy to do 90 degrees. And I just held my piece of, it's just a spoke from a bicycle, just held it with some screws. This is a piece from a